All right, so if you're running anything on AWS EKS, you're going to want to stick around. We're going to take a look at how to transform a pretty standard and, let's be honest, probably insecure workload into something that's actually hardened and secure.
So picture this. Your app is deployed, your container's up and running, traffic's flowing, everything looks great, right? But, and this is the question that should really keep you up at night, is it actually secure?
Okay, so to make this super practical, we're going to build this whole explainer around a scenario that I bet a lot of you have seen. We've got a microservice running in EKS, and it needs to talk to DynamoDB and S3. I mean, that's pretty much a textbook cloud-native setup, right?
And you know what? It's in these super common, everyday setups where we see the most frequent security mistakes. We're not talking about some super complex zero-day exploit here. Nope. We're talking about simple oversights that, frankly, can have massive, system-wide consequences.
So this slide really lays out the journey we're about to go on. Way too often, teams get stuck over on the left, in the risky way column. You grab a public base image, you hard-code some credentials just to get the thing working. Our goal is to get you firmly over to the right into the secure way. We're talking temporary roles, zero-trust networking, all the good stuff.
Oh man, this right here is probably one of the biggest anti-patterns in all of cloud security. If you see a hard-coded access key, I don't care if it's in your code, a config file, an environment variable, you have a ticking time bomb. Seriously, these static credentials, they're basically a giant, flashing neon sign for attackers.
So where do we even begin to fix this? Well, here's the thing. Your security doesn't start at runtime. It starts way before that. It starts with the container image itself. This is your absolute first line of defense. And look, it really boils down to two critical steps. First, use minimal base images. Seriously, stop pulling the full Ubuntu latest tag. It's bloated. Switch to something minimal, like a distroless image. Why? Because a smaller image means a way smaller attack surface. And second, scan everything. You've got to integrate vulnerability scanning right into your CI/CD pipeline. The goal is simple. No insecure image ever makes it to production.
All right, so our image is hardened and scanned. Awesome. Now let's tackle the really big one, getting rid of those incredibly risky static AWS keys for good. The modern AWS native solution for this is called IRSA. That stands for IAM Roles for Service Accounts. And here's the magic behind it. Instead of a key, Kubernetes gives your pod a special signed token. AWS is configured to trust that token, so it exchanges it for temporary, short-lived IAM credentials. The best part? No secrets are ever stored inside your pod. None. And believe me, the difference here is night and day. Static keys are just a permanent liability. They're a pain to rotate, and let's be real, they often have permissions that are way too broad. But with IRSA, your application gets credentials that are short-lived, they expire, and they're automatically rotated for you. Plus, you can scope the permissions down to the absolute bare minimum your app needs. It's a game changer. Okay, so our image is clean, our credentials are secure. We're feeling pretty good, right? Well, we're not done yet. What about the network? Think about it. If an attacker does somehow get in, the last thing you want is for them to be able to just wander around your cluster. It's time to build a network fortress. And the tool for this job inside Kubernetes is called a network policy. The easiest way to think about it is like a tiny, distributed firewall that lives right there with your pods. It lets you write really specific rules about who can talk to whom. This is how you build a real zero-trust network. Now, this is the really critical part to remember. By default, Kubernetes networking is a free-for-all. Any pod can talk to any other pod. It's wide open. A network policy lets you flip that default. You can start by applying a simple policy that basically acts as a deny-all firewall, just shutting down that unwanted chatter from the get-go. Okay, so once you have that deny-all default in place, you can start poking very specific holes in it. You add allow rules. So for our little microservice, we create an egress policy that says you are only allowed to talk to the AWS endpoints for DynamoDB and S3. And that's it. Nothing else gets out. Total lockdown. Phew, okay, that was a lot, so let's pull all of this together into a super clear, actionable checklist that you can literally take back to your team and start working on today. All right, let's run through this and prioritize. Number 1, the biggest bang for your buck. Swap every single static credential for IRSA. Just do it. Next up, get those network policies in place. Lock down that east-west traffic and stop attackers from moving laterally. Then, harden your supply chain. That means automated vulnerability scanning in your build pipeline. And while you're at it, enforce the use of those minimal, least privilege base images we talked about. And finally, don't forget to regularly audit your Kubernetes RBAC, that's role-based access control, to make sure pods and users only have the permissions they absolutely need and nothing more.
And that just about wraps it up. So as you go back and think about your own EKS clusters, your own applications, I want to leave you with just one question to chew on. What is the single weakest link in your cloud security right now? And more importantly, what's the very first step you're going to take to go fix it?